Right, well, thanks for joining today. Today we're going to talk about workflows and parallelism. So I'm gonna, guess I'll just share my window. Or yeah, it should be this one and this, and hopefully, um, can you verify that you see the PowerPoint tab at the moment? I think someone just joined in. Sorry about that. Um, all right. Oh, thanks, Rick. All right, so hope I didn't miss their little pop-up thing. I heard the noise. Um, okay. Well, if I hear it again, I'll jump back. Without further ado, again, today we're going to talk about parallelism, and we're also going to talk about validated content. If you've watched, I don't remember how many sessions back it was, but I think like 3 or 4 sessions ago, I was using validated content, which is a fairly new offering from Red Hat, and there we go. Sorry about that. It's fairly new, and I really recommend taking a look at it because it saves a ton of time. So if you've been building playbooks for some time, and perhaps you're using like config modules with Jinja 2 templates for routers and switches and the like, and there's a lot of toil to build those. But with the validated content, it's more like moving past, or not past, but like moving along with resource modules. So if you look at resource modules as kind of being that next step that abstract it, more away from what you need to know from the actual device in terms of like command lines. So if you look at Jinja 2, there's a lot of work there because syntax is really important in order for your templates to run. As you move into resource modules, it's less around the syntax of the device, and it's more built around structured data. So that's great because if we understand how to use structured data like dictionaries and lists and the like, we can go to the documentation and it tells us exactly what format we need, or we can look at the examples. And it's not too hard, but there's still a little bit of a level of effort there. But as we start to use this validated content, it's really built around, if you're familiar with roles, where a role is a type of a playbook, but it's purpose built and it's meant to be shareable. And you built it and variabilize it so that you can repurpose it. So if you create a role, then you could point to that role for particular playbooks, and your playbook could be very specific to that particular environment, right? So from an inventory perspective, the host that you're pointing it to, perhaps variables, or you've created variables in group and host vars and that type of thing. That's all the normal things that you would typically prepare to run a playbook. And then if you point to a role, then the role can have a very cohesive viewpoint of what it's doing. So that playbook could be very scoped, if you will. And then perhaps you need multiple roles because you're building a use case that has typically multiple touch points that you would have to configure. So you may have several roles that you orchestrate through a playbook, because you could include roles and iterate and loop through them. With the validated content, you really don't have to worry so much about the roles and how you orchestrate the roles themselves. The validated content is really like a role, like a role at a higher level that has visibility into other roles. And then most of the roles that we're talking about are leveraging the resource modules. So there's some abstraction and benefits there in terms of state. Um, if you just bear with me a second, I need to let some more people in. Okay, I think I'm good there. So with the validated content, you can think of it as a role that manages other roles, and all these roles are um, interconnected in the sense that they're providing you with the ability to configure like a greater use case without a lot of work. So it's kind of like sort of like a low code, but not quite. I wouldn't consider it like a low code or a no code, but I would consider it like easy code. So the way that the validated content works today is that we provide that to our customers in the AAP, the Ansible automation platform, and that I'll show you like how you access them in a second. And this should slow down here in a second, so I apologize for all the toggling between the screens. But they're accessible through what we call the console. So as a customer of Red Hat, you can have access to them. And the benefit again is that it's a more curated experience, and you'll see some of that today. So we're focusing really on two things. I'm building all my playbooks using validated content, and then the focus of today is around parallelism, because I want to have a workflow that has two separate work streams for two completely different types of devices, and but they do have a common goal in the sense that we're providing connectivity to a web service. So I just have a server that's running in my lab environment, and there's two ways to access it, and I'll show it to you here in a moment on the screen. So I'll give you a backdrop, but effectively there's the corporate network that has routers, and then on the front end, on the public side of things, you can access that same website through a Palo Alto firewall. So even though they're completely different, I do have several tasks that I need to automate, and that could potentially be two different teams. So one team that has more of a focus on the firewalls, a second team that has a focus on the routers. And in a common workflow, they can have feedback on if something were to pass or fail, but it doesn't necessarily mean that a failure in the network would prevent the workflow or that work stream for the firewall, from completing, right? But we would have, a state of what the workflow is at a, any given, piece or stage of that workflow, and everybody would be informed, and we would know what would need to fix, for it to be completed in its entirety, and in which component of it actually works. So we'll see that, and again, it'll make more sense as we look at the depiction. But before we go in there, I just wanted to bring up one more thing. So because the validated content is newer, there is some confusion sometimes and misconceptions of what the certified content is from Red Hat for Ansible as opposed to the validated content. So the certified content is more around modules and collections. So if you were to go to Galaxy, that's our community site where you have full access to use open source Ansible or the product, and to have access to all of those modules that currently the way that you have access to the module is through a collection. So inside of a collection, it could be composed of modules, which are typically, Python code that represents, in terms of Ansible, it's you can think of Ansible in a playbook as kind of the front end, and that's where we have, a playbook that's written in YAML that's basically just defining parameters, right? So normally we don't hard set those, we variabilize them, or we iterate through them, or blocks of tasks and things like that. But it's fairly straightforward and easy, and it's not really a programming language. Behind the scenes, normally from a networking perspective, those modules are written in Python, and that's where the data that's sent to the device, and because we're talking about network devices, I don't want to spend too much time here, that serialized data is typically the native command lines are sent to the device. But we're dealing with the parameters, right? So we may not even understand the CLI. Well, we should understand it, because we want to make sure that we know what we're doing in the network and kind of have a better understanding of what we're building. But we really don't have to focus there, because that's happening on the back end through Python scripts. If we're talking to like a controller or a device that has a REST API, then those native REST API calls, those gets and puts and posts and the like, those would be sent as serialized data. But on the front end, again, we're just dealing with parameters from the playbook. So all of those modules, we don't create them as a user. The vendors do, or contributors, in the community side of things. They put those together, and then we're consuming them. And effectively, it's been abstracted because we're using Ansible. We really don't need to understand Python, but Python, lives behind the scenes when we run those modules. So the certified content are the vendors that we work with that go the additional step to have their collections certified. And then those are available to customers that subscribe to the Ansible automation platform. So that gives them, additional support. If a module is not working, they don't go to GitHub and log an issue. They open up a ticket with Red Hat, and then Red Hat would run the triage and work with Cisco or their third parties or Arista or whoever the vendor is, and make sure that we address whatever's broken in a particular module. So that's more around the mechanics, of how we can use these modules in the wrapper of a collection that we use in the automation platform. The validated content is really, like, you can think of it as really good examples, but again, they're in the form of roles. So it's not just like playbook examples where we have to figure out how we want to stitch those together, in terms of task and things like that. These roles are very well put together, and that's what you're going to see. So the difference is the validated content is more around like roles or super roles or whatever you want to call them, and then the certified content are the modules, but they have that checkbox that they've been vetted and they're supported by Red Hat, as a product. So just to make sure everyone's clear there. So how do you see these collections and validated content? Well, if you have the automation platform, you have a private automation hub. So this is either installed on OpenShift or a VM or on bare metal, and it's really just a location, a repo of where you can pull down all of this, these collections, and also create an execution environment, which is like a topic for probably another day because there's a lot of moving parts there. But effectively, that's just a container where all of your collections are installed. And then you would either run that in your automation controller, which you may be more familiar with, like terminology like Tower. So the evolution of Tower is now the controller. Or if you're running it locally, instead of using Ansible-Playbook and installing Ansible into a virtual environment, that core Ansible engine can be installed into a container called an execution environment, and you can use those exact same containers, so you can be on the same releases of collections and dependencies as everybody else on the team. So you manage it, the life cycle of the collections in containers, so you don't have to install virtual environments, and there's no, there's less worry around folks using, different versions and things like that as they're, working on the same automation. So it's just an easier way to manage all that. But the certified collections are in the automation hub, and so is the validated content. Or you can access the console, which is like a cloud access for Red Hat customers of Ansible. And in the console, you can go to the automation hub there, and then you have access to the certified collections from there as well. But currently, the validated content is accessible through the private automation hub, but they're adding that capability into the console as well. So you can effectively either get it locally, or you can go to the web page and have access to that. But you'd have to be a customer there because you need a token, and you have to have a subscription and all that kind of stuff. So that's the difference between the certified and validated is the product, and then everything else is Galaxy and community stuff. So that's kind of the background of where to go and how you can access it through the product. This is just a real quick overview, and I kind of talked through some of this. But before we get into the demo, I just want to be clear on like the validated content because it continues to grow. So this is sort of fluid at the moment. So the first validated content is called network.base. And this is just the naming convention. So actually, it's Ansible.network.base. So that would be like a fully qualified validated content name. And then the collections are the same way, where either Ansible or like a vendor like Cisco, Arista, it would use dotted notation there too. So like a Cisco one would be like Cisco.ios, underscore config, or some other module name. So for validated content, it also has a naming convention, and network.base is the base. So this is all your basic network capabilities that are wrapped into validated content. And the way that you use them is a resource manager role, or resource underscore manager. So this role is included, like when you create a playbook using the validated content, you're going to include this role. And this role gives you access to all of the available resource modules for a particular type of device. So if you look at network devices, routers, and switches, very heavy on resource modules. Firewalls are moving in that direction, but they might not have like 100% coverage. Network devices, we've been working with them longer, so they tend to have more features that have been turned into resource modules. But even they have gaps as well. Like there's not a resource module for like MPLS as an example. Some of the more like advanced networking things, but a lot of the basic stuff or like the more common types of configurations in your network devices would have resource modules. So this is just not an exhaustive list. It's just a sampling, and it's probably hard to see these. But this would represent like if you went to the documentation, and this doesn't matter like which vendor. So this is multi-vendor in nature. So all the vendors that are certified have to have similar modules depending on what type of device they are. So routers and switches, you would expect to see the same types of resource modules, but there are differences, nuances in the data structure because their commands are a little bit different, and the way that they create their data structure, or that that model over top of the command line of how they're using the resource modules with structured data is a little bit different. But for the most part, probably 80% of it is the same. And then there's 20% of things that you would have to figure out why these keys a little bit different, or it might be a dictionary on one and a dictionary, list of dictionaries on the other. So the documentation would help you, but to make it easier, if you look at the validated content, there's these actions. So even with the network base, which is kind of generic, right, in its focus, but it has different actions. So list would tell you like all of the available resource modules that it knows about, and then you can take that list of resource modules and you can run the action of persist, and persist will go out and it will collect the configuration from an existing device that has not been automated previously. So a brownfield device, and it'll gather those configurations. It'll turn them into YAML, and then it'll save them as YAML files in your host vars. Because in host vars, it would be very specific to that device. So every device, would tend to have, nuances in their configuration. So in the host vars, it'll do all that for you using the persist action. And then if you wanted to make a change to those configurations and then deploy it back to those devices that you ran it against in that particular inventory, then you can change the action to deploy, and it'll make whatever changes that you've made to those YAML files. And we'll go into the YAML files, and I'll show you some examples of that. Another thing is read only. Like if you just want to gather the configuration or use it for like creating a dashboard or reporting, you can gather the configurations just like you gather facts and gather network resource facts from a typical playbook. You can do that using the action of gather. And if you want to determine like single source of truth, then for all of the configurations that are under the the scope of a resource module, then it'll compare the resource configurations, or the configurations that were created from the resource modules, against what's running in the running config or the startup config or some other configuration source. You can do a comparison, so that way detect gives you configuration drift check, if you will. And then if you want to change those, because perhaps your stance or your policy is only the single source of truth of what we have in those configs should be running on those devices. If somebody goes in out of band and makes a change, then I can use the action of remediate, and then it'll go with the actual configuration files from an Ansible perspective, because remediate is using the state of overwrite. So that's more of like the lower level piece of the resource modules themselves. But overwrite would completely remove a configuration and replace it wholesale with your configuration. That one works when config shouldn't be there, but typically replaced is a little bit. I would use that as a little bit more friendly in terms of if you're cautious about certain types of configurations, especially like access list and VLANs and stuff like that. Then I would feel more comfortable with replaced. So you still have the ability to use these other states. So just because remediate maps to overwrite, if I don't want to use that, what I can do is I can change the action to configure, And then configure gives me access to all the other modules underneath. So I can call a resource module directly. And by doing that, and I'm still under like this framework of validated content, then I have access to the other states. So I might want to use replaced as opposed to overridden, or I might want to use a resource module to make a change as opposed to, using the action of deploy, which goes through all of these resource modules. And if I'm not making changes across all of them, it's going to take a bit more time. So I can effectively, I can make a more focused change by dropping down to the actual resource module. And if I want to run a Jinja 2 template, because not every config, even in a router and a switch, is covered completely by using resource modules, then I can still do that for like the one-off types of configurations. So something like segment routing or MPLS or layer 3 VPN, something like that that doesn't have like an actual resource module, then I can round it out, by using some Jinja 2 templates for those, particular components of the configuration. And if I want to do some command module stuff like, show commands or some debugs and those types of things, because I'm doing like, automated testing or validation, then I can actually have access to them as well too from the action of configure. So why we would do this is just to kind of keep our configs and our playbooks uniform. And then sometimes it is like a broader thing we're doing that's easy because it pretty much does what we wanted to do already. And then when we want to do something more specific, then we just kind of go lower, drill down lower into this framework. But then we still have access to all that same data, and we're working from the same config files, and it keeps everything, collectively, it keeps everything organized for us. So it does help in that regard. So, very easy to look at too. Once you start seeing some examples of this, you'll see like, oh, okay, yeah, that's a lot easier than when I just, throw all these resource modules together myself. And then we, can go from there. So these are some links that'll be a part of this slide deck. I always leave it behind as a PDF. And if you go back to this event as a past event, you'll have the, access to the PDF. And I'll normally I also create the replay of the video, and you can access that on YouTube. So these are just leave behinds. But here's what we want to do. So without further ado, the actual demo itself. So I want to use validated content, to create all my playbooks and that type of thing. But what I'm trying to accomplish is I want the routers to have access through the corporate network. And this is just a lab environment on AWS. So, it's running in AWS. I have 2 different VPCs. So normally they can't talk to each other. So this is kind of a segmentation point here. And then I have this web server that's running on an instance in AWS that has an interface into the one VPC on a private network, and then it has a second interface that's into this public VPC. But the way that this works is you always have that private network in AWS for your VPC, and then you have an EIP, an elastic IP, that you throw in front of this so that you have a public IP. So this will be the public IP in the firewall that will create a NAT policy and create a security policy that allows web traffic to access this web server. And then on the corporate network, the challenge there is that we have an access list. So we're going to create an access list that I'm going to make a mistake on purpose, right? So I just, botched that. So when I go to check this, it's going to fail. And how we're going to check it is inside of the router. This is a CSR 1000V router. It has a guest shell. So guest shell gives me the ability to pop in there or to run commands using the guest shell so that I can do curl, and run, those types of commands from the guest shell, because the guest shell is on a separate network from like the router management and all that kind of stuff. So that way we can prove that we can have access as if we were like a separate VM. So it's just simulating that. So you can think of the guest shell as being like a separate VM instance, and we're otherwise we wouldn't have connectivity without the router, right? So we have to go through the router to have access to the corporate network to access the web server. And if we don't have an access list that allows us to get there, then we're not going to be able to connect to the web service. So this is a workflow to set all this stuff up. But again, it could be 2 different teams. So this is just a workflow, and Parallelism, it allows us to run them in parallel so that we can do the firewall things at the same time as the router. And if something were to fail, we still build the firewall constructs, but we all get notifications of what failed, and then we can fix what's wrong with the router situation, and then complete the workflow. And then everybody has completed that particular workflow, which could become like a ServiceNow ticket. And there's tons of different scenarios, like operational types of scenarios and notifications and things that would go out to say that the job is done, if you will. Right. So having said that, I'm going to pop back over here. And I forgot to turn my. Well, actually, this is probably a horrible time to turn on my video when I'm going to share all these screens and stuff. But I'll see what happens. I meant to do that earlier, so it's more personable and stuff. But I'm sorry about that. So let's go and look at the automation platform. Can someone verify that you can see this? Did it change tabs? Because I think I'm sharing the whole, not the whole screen, but this whole. Not, let me go back. It's at the okay, great. Yeah, thanks. Yeah, I'm sharing the window. That's what I'm doing. Okay, yeah, so you should be able to see it. All right, so I'll go ahead and go in here. And I'm using roles-based access just because I don't want you to have to see like all of my clutter in my automation platform because I have tons of different demos. So by using roles-based access, we should only see the ones that say config management and pan firewall, which is still quite a bit of stuff as it is. So these are for the Palo Alto, and all the config management ones are for the Cisco router topology. And it's really just 4 routers, not a big deal. So earlier I ran like a cleanup so that I removed like access list and removed the firewall policies and NAT and those types of things. So if I go to here, oh, that's actually the management one. Let me bring up, this one should be the firewall. This should not be there. Well, I think it takes a while to time out. This is probably cached from earlier. But this should time out here in a second, and we're not able to access it. Yeah. So it's dead in the water right now, so that's good. And then from the router itself, some of the routers will be able to get to it. One of them has a mistake. So we'll see that when we run the workflow. Yeah, this one timed out as well. So that's just the cached old one. And then the second tab, it doesn't work. Or if I bring up another tab of it, it's not going to do anything. Yeah, so it's dead. All right, so we do have a clean environment. So in the actual environment, if I go here, this is the workflow. And there's a lot going on here, right? So I'm going to go ahead and kick it off, and then I'll talk through some of this just to save a few minutes here. So I'm going to go ahead and launch it. And this is just a notification to say that the actual workflow kicked off with a job number. This is just a Slack notification, so I can actually open that up in a Slack tool down here, and then I'd be able to go through these. So this is job 2899, and we'll come back to that later. So you see it running here. So for us to see what's going on, we can go to output. Go to jobs. And here. Oh, that is my output. Yeah, I need to actually go into here. So this is the Cisco output. So what this is doing is it's pushing a configuration. And you see like this resource manager that I was talking about earlier. We'll go into the playbook and you'll see how this is being used. But basically what happened here is I have the validated content making the configuration change for the access list. But there's a mistake, but it's not a mistake in the sense that it's a mistake in an access list itself, like syntax. So we see that they all look okay here, but there's a mistake in the port that was open. So that'll become apparent here as we move forward. So if we go back into the jobs, and I'll go to the workflow. And sorry, this thing's going to keep popping up because different stages or nodes will be doing different things. So in this one here, we deployed the configuration. We did a validation, and then we actually did a backup. So I forgot to change that config in my repo. So we'll do that here, and I'll run it again, and you'll see it fail. And I can also show you like where the configuration is. So this one actually went into a verification, and it was good. It was able to connect, and it passed. And then the same thing here with the firewall, right? So if something were to fail, that's what these red connections are, right? So these are called nodes, or you can call them a stage. So in each one of these work streams as part of this workflow, they have a pass and fail. So the pass is green, the red is failed. So in this condition, if we had a configuration that had like a bad syntax and it just failed wholesale for some reason, then I would do a scope rollback, which would roll back the exact configuration that I sent into the device, which is different than like a backup and restoral where you back up the entire configuration of the router, and then if you have a failure, you're effectively using one of your backups before that and pushing that to the router, and it's like the entire configuration. So you're more or less that router is reconfigured, and all the protocols have to reconverge and that type of thing. With a scope rollback, we're only rolling back the configuration that was a part of that resource module. So whatever disruption is caused is very limited. So the surface area or blast area of what we have to change is very small, and we can roll it back very fast. So this one didn't fail, so it went to verify. So in verify, it's actually doing a check. And I'll go ahead and go into the output of this. And you can see that what this is doing here, and this is just the output, so I still need to show you the playbooks for more context. In the output, what it's doing is it's running a curl from each one of those guest shells in the routers. So each one of those guest shells is being tested to see if it can access that web server. So when it can access it, it says you have made it to the trusted site from the firewall. So that's just the title of the web page. So in that, I have an assertion to say if it can't, it either fails because it can't connect at all, or if it doesn't see this title, then it would fail. So each one of them were able to connect to it. But what I really intended to do was to have all of them connect, but not router one. So what I forgot to do is in the repo. So if we go into the repo here, we have these host vars. So in the host vars, in router one, this is for access list. So one part of it's the access list. The other one is for the access list interface. So that's in there as well, but they're separate. So you have ACL interfaces and just the ACLs. So in the ACLs, I actually did fix it, and I forgot to go in and change it, right? So this is valid. So what I wanted to do, and what I can do real quick here, instead of going to my VS Code and all that stuff on my laptop, is I can just open it up from here. And this is what I meant to do. And then I can save it over here as well. So if I just commit it over here, continue. All right, so now that change has been made to the repo. So now as we stand, like we actually went through the whole thing, and this should actually connect to. Yeah, so see, like these ones that didn't connect before, they can connect. So the firewall has been built. So because I did that, what I'm going to do is I'm going to go back to here, and if I run it again, my firewall will just go through, and it's idempotent, so some things won't change because we just configured it that time. But the router should still fail if I run it again because now we've changed that config. So I'm not going to go ahead and clean the whole thing out because we'd have to wait for that. I'm just going to go ahead and run it again, the workflow. So I'll go ahead and launch it again. And the router should fail fairly quickly. And if we want the firewall to fail, I can go into its config and change something to a different port or something else similar. Oh, that one it didn't even get past the first part. So here it's going to initiate the rollback. Let's see what caused that to happen. Oh, it's these sequences. What happened here is it has merged. So earlier when I was talking about the deploy, I mentioned that that'll make configuration changes. But when I do some of the other ones, if I want to use replaced, right? So you had remediate action would use overwrite, but deploy uses merged. So I can't merge into an access list like this. I need to replace. So that's why it failed by me running it again like that, because I already have those sequence numbers. So it's telling me I need to use the state of replaced or overridden. So typically this would be a great example of like, okay, I'm not supposed to use deploy here because that's using merged. If there's not another action that has the state that I want, then I just use the config action and I drop into the resource module. And in the resource module, I tell it to use replaced or overridden. So really what I need to do is, let me step all the way out of here. And we changed the config. So now what we're going to do is just run this cleanup real quick. Clean up on all three. So I think it's on the next page. This is why I wanted to do the limited view because there's a lot of them in here. Yeah, this one, clean config management workflow. All right, so let me run this real quick. It's just going to clean everything out. So this would be more like, removing a big chunk of configs as opposed to a very scoped config. And we'll just pull them out. The other thing I could do is I could go in and change the states of the those playbooks so that we could do a replace, but this will be a little bit quicker. So once this finishes, I should not be able to access the website again. The Palo Alto always takes a little bit longer because it has to run its change, but then also it has to do a commit, and the commits take a while even when you use the GUI. So while this is happening, I spoke about a lot of things, but I didn't show you. So that'll finish here, and we'll see another notification pop up. So let's go and kind of start from the beginning real quick. So these are all mainly around the routers. And then in the playbooks folder, I have the ones for the Palo Alto firewall. So the first part of the workflow was the deploy, right? So for the firewall, what I'm doing is I'm running a playbook, and you can see that I'm calling these roles. And the roles that we want to configure, and actually that just finished, is the security rules and NAT. And then I want to commit that configuration change. So once I build those rules, I'll open access to that web service, and then we'll be able to connect to it. So I'll go back to here, and I'll go ahead and log back in as config the way it should have been. And we go into here, and then we're going to run the workflow again. This time, it should fail. The router should fail. The firewall will be fine. So while that is, let me kick it off. While this is doing its thing, I'll go back into the repo. Right. So for the firewall, it's calling these roles. So the way that this works for the firewall is, and the firewall doesn't have a validated content to do all these things yet, but that is in the works. There's actually a new source plugin for EDA, event-driven automation, that Palo Alto just completed, and they're working on validated content. So you'll see similar here. I'm actually directly configuring their resource modules. So if I go back to here and we look in roles, then we have these different roles for the firewall. So we care about NAT, and we care about the security rules. So here we failed this time. So in the security rules, if I open this up, you can see that this is indicative of parameters, right? So this is the module. It's the Palo Alto Networks PAN-OS collection, and it's the PAN-OS security role. Provider is for like the login credentials, and we have a credential that I created for the controller, so it has the ability to log into the Palo Alto firewall. And then this is the name of the rules, and this has all been variabilized, right? So where are the variables, right? So if we go back here, this is the task, and if we go to like our roles, we have all the different roles, and then if I go back up here, we have our host vars again. These are the host vars for the firewall. So there's a lot of things in here that don't matter for what we're doing right now, like interfaces and those types of things. Those were built previously, but we care about the security policies, and in particular, the one for HTTP. And then we also care about the NAT rule, because we need natting, and we need some static routes so that we can get in and out of our trusted and untrusted interfaces. So these are the configurations that are important on the firewall for the deploy step of the firewall. So I'll table this for a second. So this is how we made the configuration change for the firewall. We'll look at the router here in a second. So when I go back to here, this time our verification failed. Right, so it should have failed just for just that router one, right? So when you look into here, you see it failed to connect, and this is like the private IP address on port 80, and that's because we messed with its access list. So you can see here these router 2, router 3, and router 4 routers were okay. They have port 80 open. We opened port 8080 here, so this failed. So this is an assertion to say, okay, the web server is not accessible. But because that failed, it also sent out a notification, and that was happening, at the top of the screen here. So if we went through, and we'll do that here in a moment, we'll parse through some of those. We can see that if we were on like a NetOps team or a collective team between like the firewall security team and network, we could see that this failed, and then somebody should take a look at it. Right. So when this type of thing happens, we just don't want to go ahead and roll it all back. We want to see why it failed. So for this particular step in the workflow, what we'll see is we have an approval process. So if we have an approval node, is the the valid terminology for a step of a workflow. So I can go in here, and you notice that it's running. So what happens with an approval, and because these are parallel, we can see that our firewall went ahead and verified and did a backup, right? So the backup is here to say this was a valid configuration, and then we'll do a timestamp, and this is a backup of the firewall's configuration. And if we wanted to, we could use this as a failover configuration to like replace the entire config of the firewall if it were to to fail and we had to replace it, or we could use it to check against for like a diff for like a configuration drift. So we have that as well. So that went ahead and finished, and we have notifications of that we'll go back and look at in my Slack. But this one didn't work, and we went through and we saw it just showed you that. So no sense in Tony. Don't go back into that. What are you doing? So go back to jobs and go back to here. What we care about here is this step. This is an approval step. So in the approval, you can see that it's paused here. So if I click on here, this is like, okay, hey, what happened? We do some troubleshooting, And then once we complete the troubleshooting, this could be hooked into like our ServiceNow ticketing system. If we have a ticket open and we have like these notifications for the approval as well. There's a REST API, so other systems could actually have access to these buttons. So we can either approve and then move forward, or we could deny it and we just stop there in the workflow, or we could cancel the entire workflow, which would be dumb here because like half of our stuff was good, like the firewall was okay. So what we want to do is we want to go ahead and complete the necessary troubleshooting steps. So what we would do is go back, and look at our configurations and see what we did wrong. So we know what we did wrong, right? So if I go back to here, this is what we did wrong. So I'll go ahead and I save this config after we figured out what was wrong. Just get rid of that. And then go back here. And then we think we've made the appropriate change, so we'll approve it. So it starts over, or it doesn't start over, but it starts from that point. So if I go back into my jobs and we look at the workflow, we can see that we have the Cisco config replace. So this is running in validated content. It's just running that one resource module, and it's running it with the new configuration that we just changed. So it's going to push that into the device. So this time when we do this verification again, it should pass. And it should just take a little bit of time, not too much time. And if it passes, it should do the backup. All right, so that completed. So the last part of this workflow is the backup, and then this would be a completed workflow that succeeded, as long as the backup's good. It's just about there. Then I'll show you some of the playbooks on how these work. And we'll go ahead and we'll look at the backups too. So we have the Palo Alto backups already there. So I'll go ahead and bring that up. But what I need to do for me to show you that one, I'll come back to that one because I need to share my whole screen. I won't be able to do it from a tab. So right now we had finished off the workflow. And if we go back into here just to wrap up a couple loose ends. So what did we look at so far? The firewall, we looked at the deploy step. And then if I go back here into the playbooks, right, then we have the config was for the deploy step. And what I mean by step is each one of those steps in a workflow is called a node. And a node is really a job template. And a job template maps to a playbook. So we're mapping to this pan config playbook. And then we have this pan verify. So this is the playbook that I ran to see if we can access it. So for this one, we're running this in Ansible, and it's just using the Ansible built-in URI module. So this is like an easy one if you're checking like access to a web page. Then you're just looking to see if you can connect, and your status code's 200 if it can connect. And then also we have an assertion here based off of the title of that web page, just like we did for the router, right? Otherwise, it would fail. So it either passes or fails. So we have two different messages for each state. And then we could retry. If we can't connect to it, we could give it like a couple of tries before it fails completely, in case it might take it a while to come up. So that's why these are here, but they're optional. So we were able to connect, and we can validate that again too, because these tabs, or I can create, let's bring up another tab, and it's this one, right? So we can connect to the web page from the firewall, and we also can connect from the router's perspective. And I can prove that from the router too. We could go into the router if I switch my screens. So that's pretty much the firewall. For the router, for perspective of the mechanics behind that, then I'll go back to here, and the first thing that we did is the deploy. So in this one here, we have the network resource manager role. So this is a part of the validated content, in particular the network.base, right? So we have this resource manager role that's a part of this collection. And then what we did is we wanted to look at the the access list, or we wanted to make a change for the access list, and also apply it, make sure that ensure that it's applied to the interface, right? So that's what we did here, and we're using the state of merged, and that's why it failed. So when we ran this that one time when I didn't make that accidental mistake on purpose kind of thing, and then I ran it again, then we're trying to merge an access list, which doesn't work because of the sequence number. So really with access lists, you need to use replaced. So the reason why when we ran it the second time after I made the change and we had the error and it failed and we ran it again, in that playbook, we do have replaced. So if I go back to that one, that is this particular playbook here, and it has the state of replaced. So that's why this one worked, because I went and I fixed it and ran it again, in the workflow, and it works from here. So that's why that worked. One of the ones that's interesting is before we ran the workflow, to make it easy for me to pull in all the configs, I use persist. So this is like my favorite part of these validated content modules is you can run this, and again, you can run it against any vendor, and it works the same way. You list out all the resource modules, and it'll build those configs, those host vars configs for you. And what I had to do here is I need to write those. I don't just pull them down. I need to write them to a Git repository. So initially, I'm cloning them into my EE, and then I'm committing them and then pushing them back into the repository, because I want to change the files in a repository, because I'm not working with Ansible controller locally, right? I'm not using the AWX projects folder. I'm actually using, for my project, is the Git repository. So I can pull in configs for my project, but to push them back, then I have to have credentials, and I need to either do it this way. There's also an Ansible.scm module, and then soon there's going to be Ansible validated content, or the network.base validated content will also include a network.backup. So it'll be like a very easy to run backup for any of the vendors, and it'll actually have an option to save to the repo. So it just makes it a little bit easier. You still have to provide a token, just like I have to do here. You just can't see it. It's behind the scenes in a credential. But you would provide like your username and your token, and then you could write to the Git repository. So it makes it really easy to do like a GitOps type of scenario using the validated content. So we pulled down all these configurations, and that's what built my host vars. So these host vars. So all we did in host vars is we manipulated them, but they were originally just pulled down, from the controller using the validated content, and then wherever there was, a configuration, it just creates a file, and it's all structured data. So very easy to work with. It also makes it easier if you don't understand or you're having a hard time figuring out the structured data for a particular resource module. Just go build it manually and then pull it down, and then it's going to create it for you. And then you have that as an example to use for other automations. So it's a great way to get started, to kind of kickstart it and run it that way. So in terms of what we did, we also did the backup. So here's an example of the router backup. So for the router backup, I didn't save it to a Git repository. I saved it to a server. So when you do that, you need to do the delegate commands. And the reason for that is I want to run, like as part of my backup, I want to create like folders for the backup, and I want to copy the backup from my execution environment, that container that I'm running underneath the controller. I want to copy those out to the remote server. So I need credentials. I need to be able to connect with SSH. So that's what I can accomplish using the delegate to, because I have backup server in my inventory. So when you just run it locally, it's running on that container. And a lot of people get caught around the axle there, because they're like, hey, I did my backups, but then I don't see them in the folder that I created in my server. And it's like, yeah, you actually need to do the delegate, so you make sure that you're copying them on the server and not locally where you're running, where Ansible controller is actually running, using that container. So to prove that out real quick, it's kind of the last part of this is I'm going to go ahead and share my screen real quick. And sorry that I got to jump around. I didn't, because I'm using SSH keys and stuff, I didn't have it prepared to just do it from a browser. So I'm just going to bring this whole thing up. And then I got this little tool that I use that has all the IPs that I can't remember. So we want to go into this backup server. Yeah, it's always EC2 user. Under backups. So I have two different folders, one for Cisco and one for Pan. So when we ran that backup, I probably should have went in here and deleted other ones. There's probably going to be more, but we can figure it out from the timestamp. So today is the 14th. So we ran it a couple of times. So we have both of these in here. So this would have been the later one. I'll just list them out. 3-09-14-18. Okay, what am I doing wrong? 309-1450. Oh, because I'm not the. Yeah, so these are all my routers. And router one's the one that we really made changes to for the access, where it had the bad access list. So we can go into that one. And obviously it has port 80. It'll have port 80 in it because it worked, right? Yeah, so www. Yeah, so we fixed that when I had, went back into the repo and changed it. So it pulled that config down. So this is what was pushed into the router. This is a part of, this is an access list, an IP that is a part of just setting up NAT for that guest shell, because the guest shell was kind of in the mix too that I was using. So the guest shell interface is this one. So basically, we were using a command to do a curl. We were running a curl from the guest shell. So that's how that worked. Oh, so the other part of it is just to show you real quick, is this stupid thing. All right. Backups, pan. So the latest one, 14, 1845. Oh, that's the directory. My bad. Yeah, there you go. The pan's a little bit harder to look at because it's in XML, but that's just the format for its running config. But you can do imports and exports. So you export out the running config, and then you can import it back in if you need to replace the entire config. So that one is just using XML. So sorry about that. So those are the backups, and the thing with the testing, just to make sure I covered that real quick, and then I'll finally be quiet, is back over here in the validate side of things, or verify side of things. Yeah, see here how I'm able to run from the command module. You can run these commands, these guest shell run commands. So I don't have to actually go into that guest shell. You can, if you want to. You can go into the router and then type guest shell, and then you're actually inside the guest shell. But you can run commands from your command module into the guest shell. So I told the guest shell to run the curl to the IP address of that web service. And then I just registered, the output so I could see the contents, because we're looking at that that title. So that's how that worked. So I just bring up guest shell because I like it. It's a great way to test things, and you can actually run containers and all sorts of cool things inside these routers, these Cisco routers, like the Catalyst 8000s and the older CSRs, and also just other stuff too, like Nexus switches and the like. So that's pretty cool there. So that was pretty much all I had. I know I kind of went all over the place. Sorry, I forgot to make my mistake in the beginning, so I had to go back to it. But I wanted to pause, and I want to be sensitive to everyone's time too, because we went over a little bit for this time, and just make sure if anyone has any questions or comments before we drop off. One last thing too, I'm not going to have a study group today, hands-on, because I have to go to something else soon. But I'll have another one the next iteration, the next time we meet. But yeah. So does anyone have anything before we end the recording? All right. Well, I hope you got something out of it, and I look forward to seeing you on the next one. Take care.